5? Huh, interesting. Yeah, that's weird. 88. There it is with the right page number. Yeah, there we go. 25. Ah, there it is. I thought 89 seemed weird. Okay. All of this is not really that important. You already know this. How do we find an area of rectangle? We know it's LW. So we do W times L. A square is just a special rectangle, yes? And in that square, what do we know about L and W? If it's a square, they're the same. So it's not L times W, it's L times L or W times W, right? So if we write L times L or W times W, what we really have is L squared or W squared, yes? And that's why this is called a square. That's why we call this move squaring. If we have the area of a square, so area equals L squared, how can you determine the length? Well, obviously, you would take a square root of both sides. Just of the L. So that's where we get to this symbol right here. This symbol is the radical symbol. Right? It asks you to find equal factors of x. X is what we call the radicand. Now that's a word I'm going to use all the time. You have to know what I'm speaking of. I'm speaking of that number under the radical sign. We're going to use that word a lot. All right? So you're finding equal factors of that. Doesn't matter what they are. They can be decimals, they can be fractions. It's all okay. As long as it's two equal factors. Everybody cool? All right. Then obviously, I should have written a 2 there. 2 equal factors. How do we find the volume of that prism? We already know that. It's L, W, H. What if it's a cube? What do we know about L, W, and H? In a cube. They're the same. So it's not going to be L times W times H. It's going to be L times L times L, or W, 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 or H, H, H. What's the shortcut for writing that? L cubed, or W cubed, or H cubed. If we get the volume of a cube, it equals L cubed. How could I find the sides? Well, if a square root found me the angles, then a cubed root will find me the sides with volume. This is different. This is asking me now to find 3 equal factors of the radicand. This small little 3 is called the index. I'm going to highlight that because that's another word we'll be using a lot. The index is the number of factors you need. So if it's a 3, you're finding a group of 3 factors. If it's a 4, you're finding 4. If it's a 5, you're finding 5. And so on and so on and so on. Perfect square or perfect cube is any real number which has a rational square root. Technically, square root or pen's not working, or a cube root. Technically. For our purposes, for us, A perfect square or cube has an integer root. All right, and here's what I mean by that. Don't write down what I'm about to write down. Just look. What's the square root of 25? 5. 5's an integer. So 25 is a perfect square. Everybody cool? Easy, right? Okay. But let me ask you this. What is the square root of 2.25? You probably can't do that in your head, so you would go to your calculator, and what is it? Somebody's got their calculator out. 1.5. For us in grade 10, this is a perfect square because it's got an integer root. In reality, 2.25 is also a perfect square because it's got a rational square root. Does everybody understand the difference? Right now, for you people in grade 10 and 11, when we say perfect square, we mean the top one. But be aware that you can have square roots that are perfect even if you've got a decimal or a fraction in the radicand. Is everybody okay with that? Everybody understands the difference? I mean, this does have a square root, but we're referring to these ones. Okay? Okay. Now, I'm not going to get you to do the next thing, where you list the perfect squares from 0 to 400. I'm not going to make you do that, but I'm going to do this. I highly, 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 highly recommend that you have these memorized. It will help you so much in Math 10 if you're taking Math 10 next year because you just finished grade 9. It will help you so much in Math 11. It will help you so much in whatever Math 12 you take. It is so useful. It's the equivalent of learning your times tables back then, right? Think how much easier math is when you have your times tables memorized. And I don't mean like you can figure it out. Oh, 7 times 9. 1, 2, 3, 63. I don't mean that kind of knowing your times table. I mean, if I say any two numbers from 1 to 12, you have the answer before I finish the breath of saying the second number. Do you understand what I'm saying? That level of memorization. The type of memorization that people don't make you kids do anymore, which is why math is difficult for you, because you waste brain power on doing things like 1, 2, 3, 4, 5, 6, 7, 63! Okay? Everybody understand? I would memorize these if I were you. It would make your life better in math class. It's not going to make your life better out in the real world. It's not going to feed hungry people. It's not going to put a roof over your head. But it's going to make your life easier in math class. Okay? Okay. Now, I'm just going to do a couple here, just to remind you. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100. I'm going to stop right there. Because that's enough. Even though I say to go up to 400. Let's stop for a second, use our brains. What's 10 doubled? Actually, we'll go back earlier. What's 1 doubled? It's 2, right? What happened to the perfect squares? It went from 1, and how big is that? 4 times bigger, right? Okay. What's 2 doubled? This is not a complicated question. What is 2 doubled? 4, thank you. How much bigger was the perfect square? 4 to 16, it's 4 times bigger. Everybody see this? What is 4 doubled? 8, 16, 64, 4 times bigger. So what's 10 doubled? 20. So what's 20 square root automatically? Or it's not 20 square root, 20 square. No. See, all the squares went up by 4. So this would be... No. 400. Because 10 doubled is 20, so its root goes up by 4. This is a pattern that is useful to you. It's also good to understand things like when the numbers get big, they can be broken down into smaller numbers. And we're going to come to that later. Perfect cubes, 0 to 1,000, there's only 10 of them. 1, 1, 2, 8, 3, 27, 4, 64, 5, 125, 6, 2, 16, 7, 3, 40, 7 times 343, not 344, 343, 8 is 512, 9 is 729, and 10 is 1,000. All right. That's all I'm going to do with that. I do wish to show you a good way to estimate square roots. We're not going to do all these. We're only going to do the first 3. Does 72 have a square root? Look on our list. You can see that it does not, because 9 is 81, 8 is 64. 72 is in the middle there, right? So 72 does not have a square root. But we know that it is between 8 and 9, because 8 is 64 and 9 is 81, right? Now, if we're just estimating, is 72 closer to 64 or 81, or is it about right in the middle? I'll wait while my grade 10s count. Is 72 right in the middle between 64 and 81, or is it closer to one or the other? Don't go to your calculator. I am asking you to count. This is not difficult. I will wait a while you all count. How much closer? It's 8 from 64, right? But it's 9 from 81, right? So it's a little bit closer to 64, right? So it's going to be around 8.4-ish, right? It's a little bit below halfway. And since we're just estimating, that's a good way to do it. Everybody cool? Why would I make you do that? Because if you're doing a real life problem out in the real world, you're not carrying your phone, you're not carrying you're not carrying a calculator, because you wouldn't be. It's just handy to be able to estimate these, right? Let's look at 180. Do it real easy like. Where does 180 fit? Well, it's not on the list we have, right? But I'll tell you, 13 is 169, 14 is 196. Where does 180 fit there? 13 is 169, 14 is 196. Which is it closer to? It is closer to 169. Way closer or just a little closer? Yeah, it's way closer. I'd say it's about 13 1/3. Everybody cool? Now, there is a way to do this better. I'm not going to waste your time with it. Everybody okay? All right. Skip ahead. We're going to skip all this. We're going to do a bit of work on page 27. Please go to page 27. If we had written, you already know I just showed you. What is the square root of 196? 14. So this answer is negative 14. So it's rational, right? 27. Is that on our list? No, because 25 is on our list. This is just a little bit bigger than 25, right? So what would be a good guess for the square root there? 5.1. Sure. Now here's where I wanted to get a little more complicated with you. This square root sign is covering everything here, yes? If I gave you 9 100ths and I told you it was all squared, that too would go to everything, wouldn't it? Right? So, that square root goes to everything. So this becomes the square root of 9 over the square root of 100. What is the square root of 9? 3. What is the square root of 100? 10. And then we can check. Is that right? Well, what is 3/10 times 3/10? What's 3 times 3? 9. What's 10 times 10? 100. So we were right. So this is an example of what we were talking about earlier, right? This still is a perfect square, but it's not the ones that we are talking about because it's a fraction. Everybody okay? Okay. What about this guy? Do you think he's got a square root? It would be 225 over 48. Well, is 48 on the list? No. It's 49, isn't it? So what would be a good guess for this? 225, I'll tell you, is 15. So this is about 15 over what? What is 48 really close to? 49, which would be 7. So this is about 15 over 7. So can I put an equal sign there? Doesn't equal 15 over 7. I got to put this sign there, a squiggly equal sign, because it's approximately 15 over 7. Is everybody cool? All right. So what's this guy going to be? 0.25. Yuck. Barf. Isn't that 25 over 100? So what's the square root of 25 over 100? 5 over 10. What's that? 1 over 2. And what's that? What's the other way I can write 1/2? 0.5. Everybody cool? Okay, what's the square root of f? What's the square root of f? We've just done fractional square roots like 4 times. What's the square root of f? Holy. We've just done it 4 times, ladies and gentlemen. One of the 30 of you can tell me the square root of f. 1 over 5. Thank you. Square root of 0? 0, because 0 times 0 is 0. 45, does it have a square root? Yes or no? No. Is it close to something with a square root? What's it close to? 49. It's not 49, so it's got to be less than 7, right? What's your guess? 6.7? Better not have put that in your calculator. Don't need to. Approximately 6.7. What's this one? What's I? Negative 6.7, approximately. Not going to do 21. It's 11. You already know that one. Now, this type of question kids always do it wrong, because this is the square root of 5 over the square root of 20, right? And every kid says 5 doesn't have a square root, 20 doesn't have a square root. That doesn't have a square root. Except it does, doesn't it? Because would you ever leave that fraction like that? What is that fraction? It's 1/4, which is the square root of run over the square root of 4. What is that? 1/2. Everybody cool? What about 8? Does it have a square root? Nope. What's it real close to? 9. It's almost 9, isn't it? So approximately 2.9. Everybody cool? Everybody can estimate square roots? Good. We're going to skip the next page. We are going to skip up to 30. Because 30 is where we're actually going to do the work with this stuff. All right. A radical is an expression with that symbol in it. Somewhere. Anywhere. That means you are dealing with a radical. There's two types of radicals. There's an entire radical, which is just a root sign and a radicand. Then there's a mixed radical, which is a coefficient, a radical, and a radicand. What math is happening right there between m and this square root? Multiplication. Right. So here is how we do this. And all of you already know how to do this. All of you have got a lot of ways to do this, I'm sure. I'm going to show you the ways I do it, and you can either use them or not. 72 does not have a square root. It is irrational. Up until grade 9 or 10, if you were presented with this, you would automatically go to your calculator, go square root 72, and get 8.45. Blah, 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 blah. Right? What is wrong with that blah, 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 blah? What's wrong with that? Why am I not happy with that? Pardon me? What do you mean it's too much? It's a big number. How big? You don't know where it ends, do you? Is it an exact answer? No. So the problem with using your calculator for an irrational square root is it doesn't end. Technically, to write that answer properly, you would need to write the decimals for how long? How long would you have to write the decimals of this answer? Technically. Pardon me? 5. 2. Technically, how long is that decimal if it is an irrational number? We did talk about this yesterday. Forever. So can you actually give me an answer here? No, the best you can do is give me an estimate. Yes? All right. Your calculator is estimating. We don't like that. We want an answer. Math should be pretty. You should want to take math to the prom. Math should be elegant. It should be tidy. So let's make this tidy. Since this is not tidy, we will make it tidy. And you all already know how to do this. We've already explained it. We've danced around it a little. 72 is made up of other numbers. Yes? Right? Those numbers are factors. Yeah? So if I take 72 and I break it down, 8 and 9, 2 and 4, 2 and 2, 3 and 3. What do I have there? The root of 72 also equals the square root of 2 cubed, 222, times 3 squared. Right? Because 2 cubed is 8, 3 squared is 9. Yeah? Now, what does this symbol mean? It means I'm looking for 2 equal factors. Yes? Well, 2 cubed. That is 2 times 2 times 2. Isn't that a group of 2? Of course it is. 3 squared is 3 times 3. Isn't that a group of 2? So, when I had square root of 4, the answer was 2, because that's the square root of 2 times 2. There's a group of 2. If I have the square root of 9, that is 3 times 3. There's a group of 2, so the answer is 3. So this group of 2 comes out from under the radical sign, and I get a 2. Because I'm looking for a whole group of 2, right? This group of 3 comes out. And what was left under there? This lonely, sad 2. Numbers out in front do what, according to what Madeline just told us? Multiply. So what's 2 times 3? 6 root 2. And you all already know how to do this, but that's just review for all of you. Now, there is a shortcut to this, that if you have your square roots memorized, you can make it much easier on yourself. Because isn't 72 2 times 36? 36 has a square root, doesn't it? So couldn't I write the square root of 72 as the square root of 2 times 36? And 36 has a square root. Yes, what is it? 6. So I would bring out that 6. And what did I leave under there? 2. I'm very sad. I've said this 4 times. Not one of you has done it right. What did I leave under there? What did I leave under there? What did I leave under there? Somebody say it. Say it. You're supposed to say underwear. And then I say, ha ha, I made you say underwear. So disappointing. All right, square root of 99. Your calculator will tell you it's 9.9-ish. Is that what I want? No, so break it down. I'm going to stop right there. Why? Why am I stopping at 9 times 11? What is special about one of those two numbers? One of them is prime and the other is a square root. So isn't 99 also the square root of 9 times 11? Isn't it? Okay. What is the square root of 9? 3. So what comes out here? 3. What stays under there? I made you say underwear. Thank you. What stays under there? 11. And you all already know this. It's easy peasy, right? What about 75? What should I break 75 down into? You could use 15. I wouldn't. I would use 25 and 3. Why would I use 25, Parm? 25 has a square root. So the root of 75 becomes the root of 25 times 3. 25 has a square root. So what comes out? 5 root 3. Easy peasy lemon squeezy, right? Okay, let's do 80. Break it down. How are you going to break it down? What will your first 2 branches be? Just say 2 factors of 80. 8 and 10. That's the way everybody starts. Almost. Either one of those a perfect square? Nope. So we got to break it down again. What's 8 break into? 2 and 4. Can I stop at one of those? Why? Because 4 is a perfect square, right? So I know that the root of 80 is 2 times 4, and I better break 10 down. 2 times 5, right? Does everybody agree that 2 times 4 times 2 times 5 is the square root of 80? 2 times 4 is 8. 8 times 10 is 80. Everybody cool? This symbol means I'm looking for what? Groups of what? Groups of 2. Do you see a group of 2 under there? Where? I see these 2's. So what's coming out? A single 2. What's left under there? 4 and 5. Does 4 have a square root? What is it? So what's coming out? Another 2. 2 numbers out in front. What do those numbers do? Multiply together to get what? 4. And what did I leave under there? 5. Done. Easy peasy lemon squeezy, right? What are you going to break 300 down into? It should be one step. 100 times 3. Why'd you stop at 100? Why didn't you do 50 times 6? Because 100's a perfect square. So, 100 times 3, what's coming out? 10 root 3. Easy peasy lemon squeezy. 63. What you going to break it down into? Are you going to use 21 and 3? No, that'd be stupid. What are you going to use? It's the example I did 4 times with my fingers. 7 and 9. Why 7 and 9? 9's a perfect square. If that's 9 times 7, what's coming out? 3 root 7. See how you can do this in your head? What are you doing with 32? Why 16 and 2, Rajan? 16's a perfect square. 16 times 2. What's square root of 16, Rajan? 4. 4 root 2. 363. That's a tricky one. You're going to have to break that down because it's big, right? Well, what number goes into 363? Just by looking at it. 3. 3 and 121. Can I stop there? Why? Because 121 has a square root. 11 root 3. Can everybody do this in their sleep? Upside down, backwards, left-handed, or right-handed if you're already left-handed? In space, without oxygen? Everybody can do this, right? Because all it is multiplying. When did we learn how to multiply? Grade 2. Too bad Miss Bad Crumble didn't tell you this is where it was going. Maybe you would have paid a little bit more attention. Okay, that's going from entire to mixed. What if we go back the other way? If there's a 2 out here, how many 2's are under here? 2 of them. So this is the root of 5 times 2 squared, which is what? 2 squared is? 4 times 5 is? 20. If there's a 7 out here, how many 7's are under there? 29 times 7 squared, right? If there's a 6 out here, how many 6's are under here? 6 squared. This one's tricky. What's going back under the radical sign? There's already a 12. What else? Right. 5 squared. But I got to keep that negative out in front. Everybody good? Now, I'm not going to do the math here. I don't care because you got to get out your calculator. What's important to me is you recognize that there's 2 under there, 2 out there, so 2 are under there. What if I gave you this one, though? 3 cube root 4. If there's a 3 out there, how many 3's would be under there? 3. Cube root 4 times 3 cubed. Everybody cool? All right. So I'm going to get you to practice these 6. And then I'm going to give you 3 more on the bottom. You do those 6 while I write out these next 3, okay? Go. Talk to your neighbor. You don't need me, or you don't need to do this quietly. When you get done, want A, B, C, D, E, F, try G, H, and I. Once I have gone over G, H, and I will tell you what you are to work on for the rest of this period and what you will work on if you finish your trig test early. Okay? Once I am done teaching, if you wish to prepare for your trig test instead of practicing radicals, that's cool too. Okay? What did we do with 54? I would have broken it down into 2 times 27. Why would I use 27? 27 as a cube root. What is it? 3. So that's 3 cube root. What did I leave under there? A 2. Now let's say you don't have those cube roots memorized like Parm does. Then you just break it down. 9 times 6. 3 times 3. 3 times 2. There's your group of 3. Everybody cool? Do you have to have the square roots and the cube roots memorized? No. What will it do for you? Save you time. And some of you are in dire need of saving time in math class, yes? If it's an easy question and you can save 10 seconds on the question, and you do that 10 times, all of a sudden you've saved 100 seconds. You've got almost 2 extra minutes at the end of the test. Everybody understand? All right, 144. Kids always say 12 here. Why is it not 12? Because I don't want the square root. I want the cube root, don't I? So I take 144 and I break it down. 2 times 72. Now I'm going to break that down into 8 and 9. Why would I use 8 and 9 and then stop? 8 has a cube root. What is it? So out comes a 2. And what stayed under there? 2 and a 9. So it was 18. Everybody cool? You've all seen this before. Even the grade 9 should have seen some of this before. 128. 128's a big number. I've done this so much, I can stop at 64. Actually, I can't stop at 64. I can stop at 32, and then I can stop at 16. I can stop at 16 because I know that 16 has a fourth root. It's 2. 2 times 2 times 2 times 2 is 16. So I can stop there because I know that's going to be 2, fourth root. What did I leave under there? 2 times 2 times 2, which is 8. Everybody with me? The more you practice these, the better you get at them. 162, that's 2 times 81. I can stop there because I know 81 is 9 times 9, 3, 3, 3, 3. There's my group of 4. 3, fourth root 2. 108. I know that's 3 times, that is 4 times 27. Why can I stop there? 27 is a cube root. 3 cube root 4. Square root 108. 108. I'm going to go with 12 times 9. Right? I can stop there, but I'm going to make a mistake if I stop there. Because what am I going to bring out? 3. And everyone's going to leave a 12 under there and tell me they're done. Are they? No, because 12 is what? 4 times 3. So I'm going to bring out another square root, and I'm going to end up with 6 root 3. Everybody cool? All right. Now I left you with these 3 that are harder. Why are they harder? Are they actually harder? They just look harder. They just look harder, right? Because you all know what the square root of 16 is. What is it? 4. What does x squared really mean? X times x. Isn't that a group of 2? So what's the square root of x squared? Out comes an x. Isn't y to the 4th really y and y? So how many y's come out there? 2. 1 for that one, 1 for that one. Y squared. What did I leave under there? Anything? So it's done. Finished. This really means the square root of 16 times the square root of x squared times the square root of y to the 4th. Now there's a shortcut here too. This little number should be a 2, shouldn't it? The index. So all I got to do is check. How many groups of 2 come out of 4? How many groups of 2 come out of 2? It's just division. Now, what about h? Is h more difficult, or does it just look more difficult? I got the square root of 18, the square root of x to the 3rd, and the square root of y to the 5th. What is the square root of 18? How would I break that down? I would use 9 and 2. What comes out? 3. So the 9's taken care of. What's the square root of x cubed? I can get an x out, but that only counts for 2 of these x's. What's left? 1x. How many y's can I get out if I'm looking for groups of 2? I can get out 2 y's, but what's that leave me there? 1. So what stayed under the radical sign? All through here, a 2, an x, and a y. Everybody cool? Great, you do the last one. Notice there's a little cube root there, so I'm not looking for groups of 2. What am I looking for? Groups of 3. So I like to break it down into 16, x to the 4th, y to the 6th. And these are all cube roots this time. Would anyone like to volunteer their answer? You're going to use 8 and 2 there, right, Parm? Why? So what comes out? 2. What stayed under there? 2. So that 8's taken care of. What's coming out here? One x. That covers how many of these x's? 3 of them. So how many x's are left under there? 1. Okay. What's coming out here? 2 y's. So how many y's are left under there? None. So what's left under the radical? 2 and x. And that's done. Can everybody do this? Good, because that's grade 11 pre-calc. Well done, everyone. Okay, listen to me and listen to me closely. You have until 9:15. That is 22 minutes. You are going to work on page 32, 33, and as usual with page 34, if you can do 2 of these 8, can you do all of them? If you can do 2 of these 8, can you do all of them? Right? If you can do 1 of these in 17, can you do all of them? Do you need to do the whole page? No. But if you don't do enough practice, what's going to happen when you get to the test or the quiz? You're going to forget, right? Who knows how much practice you need? You do. Okay? I expect some practice, 32, 33, and some practice on 34 to be done by the end of your trig test. Your trig test is shorter than your measurement test. You should have leftover time if you know what you're doing. Everybody cool? And you can see our next number 3 there, operations with radicals. We're going to be practicing this more to do the next thing. Everybody cool? So you're going to get even more practice when you learn the next thing anyway. Yeah? Now, obviously in number 3 there, I'd also like to go over your trig test, which means I got to get it marked. So get it done as quickly as you can. No pressure, though. The more of you that get it into me earlier, the more I can get marked before the block is even over. Everybody with me? All right, so you have now 20 minutes to work on radicals, or you can study up for trig and try and get ready for it. Your choice. Okay? While you're gone on break, I'm going to shift the desks a little so you can, and then you'll write your test when you get back. Oakley dokley? Oakley dokley. Remember, I will provide you SOHCAHTOA. I will put it on the screen behind me. The same drawing that you have on your data sheets, because I bet a million of you have lost the second formula sheet I've given you. Imagine. I'll put that up on the board behind me so you don't even have to memorize SOHCAHTOA. Okay? All right, work.